Hello, hello class. Hi, this is Dr. Tithi Banerjee, Assistant Professor of Civil Engineering of Swami Vivekananda Institute of Science and Technology. So class, in the previous class, I have discussed regarding the basics of concrete technology. And in the present class, we will be discussing regarding the history of production of cement and the types of aggregates and fine aggregates. So let's start the class. So in the previous class I have already discussed that in the most general sense of the word, a cement is a binder, a substance that binds, adheres, that sets and hardens independently and can bind other materials together. Cement is used in construction is characterized as hydraulic or non-hydraulic cement. Hydraulic cements are Portland cement, which hardens because of hydration, chemical reactions that occur independently of the mixture's water content. They can harden even underwater or when constantly exposed to wet weather. So generally, hydraulic cement are used in several kind of constructions. Okay, so hydraulic cement are those where the cement is mixed up with water and as a result hydration process undergoes, and for the hydration process several compounds are generated and which provide strength to the cement. So regarding hydration, we will take 2 or 3 class. We will discuss it elaborately. Okay, regarding the hydration process. Now, we need to know the history of cement. It's quite interesting because how cement was first processed, we need to know that. To have just a brief idea of the origin of the cement, and it is important to understand because without knowing this we will not be able to generate an idea on the current origin of cement. So to know the present we need to know the past, as we all know that present is the key to the past. Now, John Smeaton made an important contribution to the development of cements. He planned the construction of the third edition lighthouse in the English Channel. So to construct that, he needed a hydraulic motor that would set and develop some strength in the 12-hour period between successive high tides. So what is motor? Motor is nothing but a blended and binded substance. Now in 1824, Joseph Aspdin patented a similar material which he called Portland cement, that is hydrated cement, because the render made from it was in color similar to the prestigious Portland stone. So in 1884, Joseph Aspdin patented a similar material which is called Portland cement, and it has been named after the prestigious Portland stone. Now the investigations of A.L.J. Cat led him to prepare an artificial hydraulic lime by calcining an intimate mixture of limestone and clay. What is calcining? Calcining is nothing but reaction with calcite, that is calcium carbonate, which is the major component of limestone. Okay. And further, in 1845, Isaac Charles Johnson burnt a mixture of clay and chalk till the clinkering stage to make better cement. Clinkering stage, which means when the cement form a clinker. Clinker is nothing but a compound or several kind of compounds which are formed after the hydration of cement. And the German standard specification for Portland cement was drawn in 1877. The British standard specification was first drawn up in 1904. The first ASTM specification was issued in 1904. In India, Portland cement was first manufactured in 1904 near Madras by the South India Industrial Limited. But this venture failed. Between 1912 and 1913, the Indian Cement Co Limited was established at Porbandar, that is in Gujarat, and by 1914 this company was able to deliver about 1,000 tons of Portland cement, which is, in the previous class also I discussed that Portland cement is nothing but a hydrated cement, because without hydration, without mixing of water, a cement cannot be able to bind or adheres or to provide strength, because the strength generates after the hydration process, and because of the hydration process several compounds form which provide strength then to the cement. Now I will give you a brief description of manufacture of Portland cement, and I will discuss in elaborate also when I will discuss the hydration process of cement. I will discuss it in elaboration about the manufacture of the Portland cement. Now, cement is made by heating limestone, that is mainly made up of calcium carbonate, with small quantities of other materials such as clay, to near about 1450 degrees centigrade in a clean is a burner or a kind of burning system container which helps to burn out a cement in a process known as calcination, whereby a molecule of carbon in calcination, a molecule of carbon dioxide is liberated from the calcium carbonate to form calcium oxide or quicklime, which is then blended with other materials that have been included in the mixture. The resulting hard substance called clinker is then ground with a small amount of gypsum into a powder to make ordinary Portland cement. The most commonly used term of this kind of cement is OPC. Okay. So I will discuss the detailed manufacturing process of Portland cement in the next class while making you understand the process of hydration. Now there are several types of cements, that are ordinary Portland cement, rapid hardening Portland cement, low heat Portland cement, sulfate resistant cement, blast furnace slag cement, machinery cement, white and colored Portland cement, air entertaining cement, Portland pozzolana cement, high alumina cement or oil well cement, quick setting cement, hydrophobic cement, expansive cement. Each cement has a different aspect for several kind of construction, okay, which will be discussed later on. Okay, now regarding cement, we have already received a brief idea regarding its manufacture, regarding its process of manufacture, regarding its origin of history, how a cement form and its major chemical composition, and what is its role and usage. So in the previous class I have already discussed that a concrete is made up of cement, water and aggregates. So regarding cement, we have already developed a preliminary idea. Now we will develop a brief idea on aggregates. So now what is a aggregate? So aggregate is the broad category of basic material used in construction, okay, including sand, gravel, crushed stone, slag, broken bricks, etc., etc., etc. So in the previous class also I have told you all that aggregates should be generally should be naturally occurred. So a piece of stone is a kind of aggregate that can be of several origin. It can be igneous origin, it can be metamorphic origin, it can be sedimentary origin, okay, and that crust aggregates also are naturally occurred, but it is also the disintegrated part of a broken rock, okay, which got weathered and eroded and formed crushed aggregates, okay. And there are several shape and size of aggregates also. So size, I have told you that it can be of gravel size, it can be of cobble size, it can be of pebble sized. There are several size. There can be several sizes of aggregates. Now there are few properties or few requirements of a good aggregate. What are they? It should be chemically inactive. It should be sufficiently strong to provide strength. It should be hard enough. It should be durable. Yeah, obviously durable, because if it gets weathered or eroded very quickly, it cannot provide strength to a to a concrete, okay. The pores should be limited. Yeah, if the pores are enormously present, then the water will automatically erode or weather the aggregates. So we have to take into consideration that the pores of aggregate should be limited. That's why, as we all know that sandstone are porous, that's why sandstone cannot be a good aggregate, whereas basalt, which is a hard and compact igneous rock, so it is less porous. So basalt, a piece of basalt can be a good aggregate. A piece of granite can also be a good aggregate. But in case of sedimentary rock, that is sandstone or pumice or limestone, that cannot perform as good aggregates because they are porous. It should have a rough surface, because if the surface is very smooth, it cannot provide additional frictional force, which generally strengthen the concrete. And it should be well graded. Yeah, obviously, if we don't know about the gradation, we will not be able to use it in proper field. So these are the requirements which are very important to be a good good aggregates. Now, depending upon the size of their particle, aggregates can be classified as fine aggregates and coarse aggregates. Aggregates whose particle size pass through 4.75 mm IS sieve. Sieve is a technique or tool which is generally used for sieving. So, aggregates whose particles pass through 4.75 sieve are termed as fine aggregates. Most commonly used fine aggregates are sand and crushed stone in powder form. However, sometimes sukhi and ash or cinder are also used. Now, coming to the fine aggregates, I have already told that sand is a type of fine aggregates. It consists of small angular rounded grains of silica, depending upon the source from which it has obtained. Now, generally, sand are weathered and eroded product of any kind of rock. It can be igneous origin, it can be of metamorphic origin, or it can be of sedimentary origin. Okay. Now, there are two types of sand. It is river sand. One is river sand. It is obtained from the banks and beds of rivers. It may be fine or coarse. Fine sand obtained from beds and banks of rivers is often found mixed with silt and clay, so it should be washed before use. But coarse sand is generally cleaned and excellent for use, especially for plastering. Okay. Sea sand, another type of sand. It consists of fine rounded grains of brown color, and it is collected from seashores or sea beaches. Sea sand usually contains salts, and while using that in mortar causes disintegration of the work in which it is used. In RCC work, these salts will attack reinforcement if salt content is high. These salts may cause efflorescence. It should be used locally after through washing. Okay, so in RCC work, the sea sand should be washed off because salt is present, and the salt will affect the reinforcement concrete work because it will cause damage in the reinforcement. So before using sea sand, it should be washed off. And crushed stone, it is obtained, another kind of fine aggregates. It is obtained by crushing the waste stone of quarries to the particular size of sand. Sand obtained from by crushing a good quality of sand is excellent fine aggregates. Mortar made with this sand is usually used in good work. So this what I have now discussed, that a good crushed stone is a kind of fine aggregates which is obtained by crushing the waste stones of quarries, and sand obtained from good quality of rock, that is almost unweathered rock, can be served as good kind of qualitative kind of fine aggregates. Okay, so these are the fine aggregates. So we will be discussing on coarse aggregates in the next lecture. Thank you, class. Thank you for your patience. Thank you.